Multiplication of a vector by a scalar. Suppose vector A is any vector and n a scalar. By vector NA we mean a vector whose magnitude is mod of n mod of vector A. That is, n times the magnitude of vector A and whose direction is that of vector A or opposite to that of vector A, depend upon that n is positive or negative. If n is equal to 0, then 0 vector A is equal to 0. Important results. Mn vector A equals m into n vector A. N into vector A plus vector B equals n vector A plus n vector B. M plus n into vector A equals m into vector A plus n into vector A. Components of a vector. Let P be any point in space with coordinates x, y, z. Then coordinates of the points A, B, C are x, 0, 0, 0, y, 0, 0, 0, z respectively. Suppose now that position vector of P is vector r. That is, vector OP equals vector r. Also, let cap I, cap j, cap k be the unit vectors along the three coordinates axes. Now OA equals x. It implies vector OA is equal to x cap I. Note that x cap I is a vector whose magnitude is 1 into x equals x and whose direction is that of the x-axis, and this is precisely the vector OA. Similarly, vector OB is equal to y cap j. Vector OC is equal to z cap k. From the triangle OPQ, vector R equals vector OP equals vector OQ plus vector QP equals vector OQ plus vector OC. Also from the triangle OAQ, vector OQ equals vector OA plus vector AQ equals vector OA plus vector OB. Thus, vector R equals vector OA plus vector OB plus vector OC. Vector R equals x cap I plus y cap j plus z cap k. Hence, if P is any point with position vector r and coordinates x, y, z, then vector r is equal to x cap I plus y cap j plus z cap k. X, y, z are called the components of the vector r. Mode of vector is square root of x square plus y square plus z square.